Hello friends, welcome to my channel. In this video, we will discuss SSC JEE mechanical paper. This is part 2 of this series. Exam date 11th December 2020, shift 1, 10:15 am paper. Already solved up to question number 116 in part 1 of this video series. So question number 117 onwards we will solve in this part. Question is, brake thermal efficiency of a 15 kilowatt IC engine is 30% if the fuel used has calorific value CV 40 megajoule per kg, then fuel consumption rate in kg per hour is how much? So MF we have to calculate. Fuel consumption rate, mass of fuel used or consumed. Brake thermal efficiency how much? It's 0.3 or 30%. Then brake power how much? 15 kilowatt. Brake power is 2 pi nt by 60. This is in watt. For kilowatt you have to divide 1000 again. Then calorific value CV also 50 megajoule per kg. So brake thermal efficiency, it's equal to brake power divided by mass of fuel into calorific value. We have to calculate m dot f. Mass flow per second. 15 kilowatt, it's kilojoule per second or 15 kilojoule per second divided by brake thermal efficiency 0.3, calorific value 40, it's in megajoule, we will convert it to kilojoule per kg. So 40 into 1000 kilojoule per kg. Kilojoule, we will get kg per second. But question asked in kg per hour, we have to calculate. So again, (15 into 3600 into 10.3, we will write 3, 40, 1000. Then finally 4.5 kg per hour. From option A is your correct answer. Next question. A Francis turbine has an overall efficiency of 83%. If it develops power of 500 kilowatt under a net head 3000 centimeter, the discharge through turbine in meter cube per second is how much? So data given, overall efficiency how much? 83% or 0.83. Power P equal to 500 kilowatt. Head how much? Net head centimeter or in meter 30 meter. We have to calculate discharge. Q dot we have to calculate. Then power is your shaft power or SP. No other data given. Okay. overall efficiency shaft power divided by water power. Water power we know rho g h q h net and q. Rho how much? Water density into g directly 9810 into h net 30. Q value we have to calculate. Put the values. .83, then shaft power 500 into, it's in kilowatt, so 1000, then this one we will write 9.81 into 10 to the power 3 into 30 into Q. 9.81 we will write 10, then 1000 into 30 into Q, then 10, 10, 30, 5 by 3, Q equal to 5 by 3 into 100 we will write here 83, we will write 80, 0, 0, 4, 5, 25 by 12, so 2 point something. 2.05. B is your correct answer. This one not possible, this one also not possible, D also. 2.5, 2.5 means it should be around 24, 6, 30. It's 25, so it's around 2.05. B is your correct answer. Next question, subcooling in a vapor compression refrigerating system dash enthalpy of liquid refrigerant below saturation level. So vapor compression refrigerating system. pH diagram we will draw. Vapor compression system. One to two compression, 2 to 3 condensation, 3 to 4 throttling, 4 to 1 evaporation. Subcooling. Subcooling means change the color. In liquid region you have to do subcooling. 3 dash 4 dash. H3 equal to H4 and H3 dash equal to H4 dash. And from this graph also clearly you can see H3 is greater than H3 dash. So enthalpy decreases. Subcooling this area. Instead of 3 you will go up to liquid region. This one liquid region, this one vapor region. So subcooling in a vapor compression refrigerating system reduces enthalpy of liquid refrigerant below saturation level. Your saturation level is this one, saturation point, this line saturation line, here also saturated vapor line, saturated liquid line. D is your correct answer. Next question, in a free vortex flow The flow is free vortex flow. Fluid motion, fluid mass rotates due to conservation of angular momentum. No external torque or energy. No external torque or energy is required. Then equation B into R is equal to constant torque, irrotational flow, irrotational. So from option we will check neither rotational nor irrotational. Irrotational flow, rotational or irrotational. Rotational. So B is your correct answer. Dash boiler is an example of once through boiler. Once through boiler means supercritical boiler. Supercritical boiler. No drum. Pressure greater than your critical pressure. Critical pressure is 221 bar, 221.2 bar. This one is your critical pressure. So from option we will check once through boiler, Benson boiler, yes. A is your correct answer. Critical temperature of water in degrees is how much? So already discussed. Critical pressure 221.2 bar. Critical temperature is 374.15 degrees Celsius. From option degrees, in degrees, yes. C is your correct answer. The rate of steam generation in water tube boiler in comparison to fire tube boiler. Water tube boilers are bigger units, size also bigger, because the rate of steam generation is more than, if you compare with fire tube boiler, water tube boiler rate of steam generation is more. Fire tube boilers generally in small units, sugar mill, rice mill, and in small locomotive boilers also you will get fire tube boilers. So rate of steam generation is more. C is your correct answer. Fusible plug is used in a boiler. Fusible plug. Mounting and accessories both are important. It's a mounting of boiler, fusible plug, to extinguish the fire. Material is antimony and lead alloy. It's a alloy of antimony and lead. So extinguish the fire. A is your correct answer. Superheating the steam, superheater. Preheat the steam, air preheater or APH. Discharge excess of water. So A is your correct answer. Refrigerant 22 has chemical formula. So R22 chemical formula. This one R22 R022 MnPq m minus 1 n plus 1 then p. This one represents carbon, hydrogen carbon m, hydrogen n, then fluorine p, chlorine q. N plus p plus q equal to 2m plus 2. This formula you have to remember. R022 022. So m minus 1 equal to 0, m equal to 1. Then n plus 1, this one n plus 1 equal to 2, n equal to how much? 1. And m represents carbon, n represents hydrogen, then your next 2, this represents your p equal to 2, fluorine, then chlorine. How you will get? N is how much? Q value we have to calculate, 2m plus 2 minus n plus p. M how much you got? So 2 plus 2 4 minus n is 1, then p equal to 2, 1 plus 2 3, how much you will get? 1. So carbon, hydrogen, then fluorine, then chlorine. Carbon how much? M 1, H also 1, fluorine 2, chlorine 1, or you can write CHCl F2, monochloro difluoromethane, from option CHCl F2. C is your correct answer. This one you have to remember. M minus 1, N plus 1, then P. Carbon, hydrogen, fluorine, chlorine. This sequence also you have to remember. Then N plus P plus Q equal to 2M plus 2. R22, R11, R12. Examples of saturated hydrocarbons. Next question. If density of mercury is 13.58 gram per cubic centimeter, pressure of 4 kilopascal is equivalent to how much? So in terms of head of mercury, you have to calculate pressure. P equal to rho GH formula we have to use here. So rho of density of Hg, how much given? 13.58 gram per cubic centimeter. So we will convert it to kg per meter cube. 13.58 kg divided by 1000 into centimeter means 100, cube divided by meter cube. So how much you will get? 13.58 into 10 to the power 3 kg per meter cube. Or if you know the density of Hg also, directly you can write. Or otherwise you have to do this one, this much calculation. Then P equal to rho GH, rho Hg, G into H into this one you have to calculate. Head in terms of Hg. HHG equal to pressure. How much pressure? 4 kilopascal. 4 into 10 to the power 3 divided by density of mercury 13.58 into 10 to the power 3 into G is 9.81. We will write 10 4 by 13, 0.3. So 0.3 by 10, 3 by 10, approximately 0.03 meter of Hg. Options are in mm of Hg. So again multiply 10 to the power 3. How much you will get? 30 mm of Hg. From option A is your correct answer. This is the end of this part of video series. Thank you friends. Thanks for watching my video. Thank you.